Okay, if you looked at video 1 on standard deviation calculation, this is now video 2, and we're going to substitute a different formula for calculating sum of squares and greatly improve the efficiency of the calculation. Okay, always best to begin at the beginning. So we're going to now calculate as step 1, the sum of squares, and remember in the last video we calculated it using this formula. We took every x value, we subtracted the mean from it, we got the difference, and then we squared the difference, and then we added up those squared differences, and that gave us the sum of squares. We're going to substitute this formula here for that. To execute this formula, we're going to square every x value that we have, and then we're going to add them together. And that's the sum of the squared x values right there. Okay, to the right of the minus sign, we're going to sum all of our original x values, so we're just going to add them all up, and then we're going to square that sum, and then we're going to divide by n. Okay, so square the x values and add them up. Over here, we sum the x values without squaring them, but then we take the sum and we square the sum and we divide it by n, and we just subtract the two terms. It's going to give us the exact same answer. Those two formulas will give us the exact same answer, and this one though is preferred. It's going to be much easier to calculate standard deviation. Here's an example. I have a set of x values, very simple set, 4 values altogether, 2, 3, 4, and 5. I want to get the sum of the squared x values, so I have to square the x values. So I'm going to make myself a column called x squared, and I'm just going to take the square of every value. So 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. Those are my squared x values. If I add them up, I have the sum of my squared x values, and that's 54. If I add up my original x values, 2, 3, 4, 5, sum those, I get 14. This is what we should do to start the calculation of the sum of squares. It gives us this value, the sum of the squared x values, and it gives us this value, the sum of x. Now I just have to plug those values into my expression here. So sum of the squared x values is 54. Sum of the x values is 14. I have to square it. I have to divide that by n. Okay, so if I square 14, that's 196, and I divide that by 4n, I'm going to subtract that from 54. So 196 divided by 4 is 49, and 54 minus 49 gives me a sum of squares value of 5, which you can see right here. Okay, so we have calculated our sum of squares, which is 5, and step 2 is going to be to calculate the variance. So remember that the calculation of the variance depends upon whether or not you're trying to calculate sample variance or population variance. To calculate sample variance, we're going to take the sum of squares and divide by the n of the sample minus 1. To calculate population variance, we take the sum of squares and divide by the n of the population. So for this example, let's just consider this as a sample variance problem. So we're going to be using this little expression right here. Okay, so calculating the variance, sample variance rather, is simply a matter of taking the sum of squares, putting it in the numerator, and dividing by n minus 1. Now remember, we had 4 x values, so n minus 1 is going to be 3. So our variance is going to be 5, the sum of squares, divided by 3, n minus 1, because we're calculating the sum of squares, we're calculating the variance for a sample. And so our sample variance then, 5 divided by 3, works out to 1.67. Now we move on to step 3, which is the calculation of the standard deviation. Okay, so remember, the standard deviation is just the square root of the variance. So we previously calculated sum of squares, next we calculated the variance, and to get the standard deviation we simply take the square root of the variance value that we acquired. So standard deviation is equal to the square root of 1.67. And taking the square root of 1.67 gives us a standard deviation of 1.29. Now let's summarize the steps. In this process, the first step is to calculate the sum of squares. I'm recommending that we use this method to calculate sum of squares for all problems. Step 2 is to calculate the variance. We have to determine whether or not we're being asked to calculate a sample variance or a population variance. If a sample variance, then we take the sum of squares and divide by n minus 1. If it's a population variance, sum of squares divided by n. And then finally, step 3 is whichever sample variance or population variance formula we used, we're going to take the square root of the variance in order to obtain the standard deviation. Okay, and that's it. I hope this helps.